Bam! Mr. Taru. In this video, we're going to be looking at the ambiguous case for the law of sine, our third in a series of 3 videos where we introduce the fundamentals of law of sine and cosine. In the description, you'll find a link to our introduction to the law of sine, introduction to the law of cosine, and a link to my webpage where you can find old videos and applications of law and cosine, such as questions involving navigation, such as bearing questions and such. So we're going to start off here with an example saying that angle A is 22.62 degrees, A is equal to a length of 5, and C has a length of 13. Now, with all problems, even though we're in trig, it's kind of basically a geometry question, you should always start with a picture. So I'm going to just draw a triangle, whatever, don't care what it looks like, put down a measurement of A, lowercase a, b, lowercase b, and then c. Remember that your uppercase letters are your labels for angles and your lowercase letters are for sides. And just start putting in the information that we have. We have angle A is 22.62 degrees. We have side A is equal to 5. And C is equal to 13. Now, of course, I know what this really looks like, and we're going to be using and building this lesson all off of versions of this triangle to let you see the connection both geometrically, and I'm going to do a lot of review in terms of geometry and what's actually going on, not just give you like a little step to do and follow and you don't really understand why. Because of all that, if you want, I'm going to put timestamps into the description so you can jump ahead to each of the 4 parts of this video, by the way, as well. So what's going on here? Well, when you work with the law of sine and cosine, well, if you can start the problem with either a side-side-side or a side-angle-side pattern, those are congruency theorems from geometry. They're also the pattern of the information that is going to allow you to start the solving of these oblique triangles with the law of cosine, which means there's no possibility for there to be an ambiguous situation. But here, when you look at how the information is given, we have information about an angle, information about a side, and information about another side. You can skip over one unmarked part, but not 2. You can't say that this is angle, skip unknown, side, side, angle, side, side. If you spell that out, you're going to be saying a bad word, right? We don't want to do that in math class. So if you say this backwards, side, side, angle is not a congruency theorem in geometry, and thus this is the situation where it is the ambiguous case for the law of sine. There might be 1, 2, or even no triangles that we can create with this given information. And I'm going to start this lesson with an understanding of geometrically what's going on. When I realize that information is given in terms of this pattern of side-side angle, maybe it's because I'm right-handed, but I always like to, and this is the only one of these questions where I really care about drawing a triangle in some reasonable sense of to scale. We have angle A, and I always put my fixed angle on the left-hand side, and that was 22.62 degrees. Now that may be more like 30 or 40 degrees, but that's not necessarily important. I want one of the sides, because when you have the side-side angle pattern, there's always going to be a known piece of information opposite the given angle. Well, we're given angle A, so then this is going to be side A, and that is equal to 5. And I want the other known side to be over here. So I'm going to put the 13 here. It's identified as side C, so this is going to be angle C here, somewhere, and then this is angle B. So here's the drawing that we're working off of. Now, if you're doing this problem in terms of purely understanding the geometry that's going on, like I did my original video for this topic, link in the description, I start off by saying, okay, you're basically going up a ramp of 13 units at an incline of 22.62 degrees. How high, let's find out, how high off the ground basically would you be? What is the measure of that height? Well, if you're looking for the measure of some side, Now, I don't know if this h is going to be 5. It might be more than 5, less than 5. I don't know. I'm just going to find out if you travel 13 units up an incline of 22.62 degrees, how far above, the other side of the triangle, if you will, are you? Well, that's what? Angle, opposite, hypotenuse. If you look at just this triangle here, we're going to be working mainly with oblique triangles, but if you want to measure the height of that, you're going to be working with a right triangle. We have the sine of 22.62 degrees is equal to the height of this sort of ramp, if you will, or triangle, the way it's over 13. And when you multiply both sides by 13, you get basically 5. Oh, well, the side opposite the given angle was 5. So as it turns out, the information that I gave you is not really an oblique triangle. The side opposite the given angle is actually the height of the triangle. This is nothing more than a right triangle. This is a scenario where when the side opposite the given angle is equal to the height of the triangle, there is one triangle, and it happens to be a right triangle. In this case, this is basically a Pythagorean triple. It's that triangle that we have a 5, 12, and a 13. And I'm not necessarily worried about angle B. I want to focus on the other scenarios here. This is the framework of how we're starting off on this, this journey that we're going to go through. And I'm going to write down what I repeat over and over again at the end of the video. But when the side opposite the given angle is equal to the height, then you are given actually, and you wouldn't know it initially, but you are actually given a right triangle. And you wouldn't actually have to notice that. You can just go straight away right into working with the law of sine, and you'll get a right answer, no problem. You'll just realize that the first angle that you find, angle C, which is opposite the given side of C, comes out to be 90 degrees. And that's when you're going to know that you were given a right triangle. Now let's take a look at another example. Let's say that we have measure of angle A is 22.62 degrees. A now is going to be equal to 4, and C is still equal to 13. Now we have a little secret here, right? We know a little bit of inside information. This is not going to make a triangle, right? We can take this information, draw it out, and do one of two things. Recognize that it's side-side angle, and then work through the sine of 22.62 is equal to h over 13, and compare the side opposite the given angle to see if it's longer or shorter than the height. We know that the height now is 5, 4 is less than the height, and so this is going to be a situation where there is no triangle that we can make out of this information. But what if you didn't check that ahead of time? What if you just realized that you said, okay, side-side angle, I know a side and its corresponding or opposite angle. Start working it out. We have that the sine of 22.62 degrees over 4 is equal to the sine of C over 13, and you're going to find angle C first because we're given side C. We're going to multiply both sides by 13. Then to solve for angle C, we're going to apply the inverse sine function to both sides of the equation. Type this into your calculator, and it's going to just give you an error or tell you that it's undefined. And then if you're like some of my students who are just kind of moving through the process and hitting the buttons on the calculator, not thinking too much, you're going to start typing it over and over again. You're going to raise your hand, ask me to come over, and tell me, hey, what's going on here? Why am I getting an error? Why is my calculator not telling me the answer to this? Must be something wrong with it. Nope. It's because, well, the side opposite the given angle is too short. It is shorter than the height of this triangle. You type all this into the calculator and you're going to try and take the inverse sine of this value. Remember, sine as a function gives you an answer as large as 1 and as small as -1. So when you then try to do the inverse sine, you cannot plug in a number that is either larger than 1 or less than -1. And I don't know what this numerical value is for 13 sine of 22.62 over 4 is, but I can guarantee you it is larger than 1. That's why the calculator is telling you it's undefined. So, ambiguous case, how do you know if there's no triangle? You just simply try to solve it and it doesn't work. Okay, so for example number 3, we're going to come in. We have that inside information that the height of this triangle is 5. We're going to make our third example have an angle A value of 22.62 degrees, and now side A is equal to 7 and side C is 13. Remember, we're looking at this as if we don't know this inside information. We're just given some information. Let's solve it. Solve for this, solve all the parts of this ambiguous triangle. Okay. A, B, C. You're going to initially just sketch this out, not worry about the shape of it. Label your triangle, identify that side angle pattern, and then go if you'd like. I want to take another second and redraw this to help me see the geometry better. Not necessary, but I like to. So the known angle, lower left-hand corner, 22.62 degrees. Make sure that you're not going to make sure, it's just going to happen, but you're going to be given some length adjacent to that angle. So side C is 13, putting angle C in the bottom right-hand corner, and then angle B is up here at 7, which means that this side, angle B, is up here on the top of this triangle, and opposite angle A, we have that length of 7. Okay, I'm going to go ahead and slow down a little bit, talk about the geometry of what's going on here. You can certainly solve the question purely by understanding the geometry. Sine of 22.62 is equal to h over 13. Find the height of that triangle. We know, of course, it's going to be equal to 5. What's going on, by the way, is anytime the side opposite the given angle is larger than the height of the triangle, but shorter than the adjacent side, you're going to have two triangles. That's the geometry. That's when you know that there are two triangles. You know that by either checking with sine function the height, comparing 7 to the 5 and the 13 and know that there's two triangles, or do some kind of like little shortcut thing that your textbook might tell you, which I'm about to get to after we review the geometry. Here we have what's it going to be, knowing that there's two triangles. That is nowhere near being perpendicular, but you're going to have basically two triangles. And I'm going to highlight this with red instead of yellow. You're going to have the original. We're going to have angle A, B, and angle C is going to come out to be an acute measure because that's all inverse sine can give you. But then we have this red triangle, which is going to be the second triangle that we have to solve for. And we're going to have to figure out how to come up with that second measurement of C. This triangle right here. We have a height of 5, okay? We have a side here, which is given to us as 7. And if we take this length of 7 and allow it to move with a compass movement. Now look, angle A is fixed, it will not change. Side C is fixed, it's 13, it will not change. Side A is 7, it's 7 units long, it will not change. However, angle B is not given, angle C is not given. We're indeed going to find two different answers for angle C and thus two different angles for angle B, measurements for angle C and B. And side AC is also variable. Fixed angle, side, variable angle, variable side. That's why side angle is not a congruency theorem in geometry. As you allow that side of 7, that length of 7, the measurement for A, rotate off of the end of side C, you're going to have what? You're going to have, well, I guess that was different, an isosceles triangle, and in an isosceles triangle, the base angles are equal. Now we're about to find the measure of C sub 1, this acute measure right there. The other measure for angle C, what we're going to call C sub 2, this measure right here, Well, if this is an isosceles triangle, you saw me make this movement with my compass, so you know that this white segment is the same as this red segment. The base angles of an isosceles triangle are equal, so whatever this measurement comes out to be is the same thing as this measurement. And then if we extend this segment and look at these two angles right here, these are two adjacent angles that are creating a straight line. They're supplementary. They're a linear pair. And this other measure of c sub 2 is equal to 180 minus c sub 1. See, when you have two possible triangles with this ambiguous case for law of sine, you're going to find the first angle. It is going to be acute because that's all inverse sine can give you. And then you're going to take that first angle that you find, stop your problem, subtract it from 180, and find a second possible measure for angle 2. So let's go ahead and do that right now before I keep talking and make this video run on too long. We know an angle, a side opposite that given angle, in side 13. I hope I said that right. So we have sine of 22.62 over 7 is equal to the sine of C. We're finding sine C again, angle C first, because we know side C. That's over 13. 13 sine of 22.62 degrees over 7 equals the sine of C. C is then equal to the inverse sine of 13 times the sine of 22.62 degrees over 7. C sub 1 is equal to, drum roll please, 45.59 degrees. We're going to find angle B by just simply taking these two angles away from 180 and then finish that up. But first let's talk about the second triangle. Is there a second triangle? We're going to take this measurement. We're going to subtract it from 180 degrees. This is going to be the possible C sub 2, 134.41 degrees. Now, we may have done the sine of 22.62 is equal to h over 13, found that the height of this triangle is 5, know that the side opposite the given angle is longer than 5 and shorter than 13, thus there is a second triangle. And there is a second triangle. C sub 2 is equal to 134.41 degrees. If you didn't do a height check, here's all you have to do. Is the second possible measure of the first angle that you found, in this case C sub 2, plus the original angle of 22.62 degrees, is that less than 180 degrees? Because if so, voila, you have a second triangle. If the new second possible measure of the first angle you found plus the original angle is, if that ends up being greater than 180 degrees, well, you can't make a triangle with two angles that are already over 180 degrees. So when you're working with the ambiguous case for law of sine, you just set that sucker up. You do law of sine. If it comes out to be undefined, then either you type something in wrong or there just simply is not a possible triangle. You find that first angle, you subtract it immediately from 180 degrees, you find a new possible second measure, you add that with the original angle, whatever it may be, in this case angle A. If that sum is less than 180, you have a second triangle. If it's over 180, you do not. And you just continue and find that one particular triangle. So let's finish this problem up. With the measure of 22.62 and 45.59 degrees, the measure of angle B, this measurement right here, is equal to 111.79 degrees. And then you can find side B. In this case, I would go back to the law of cosine if you've learned it already. My book introduces law of sine before law of cosine, so we're going to say that B over the sine of 111.79, whoops, you could also do law of cosine if you know it, is equal to 7 over the sine of 22.62 degrees. So B is equal to 7 after we multiply both sides by the sine of 111.79 degrees. 7 times sine of 111.79 degrees over the sine of 22.62 degrees is equal to, not off the top of my head, 16.9 units. So now we have all the information about this first triangle. And for our second triangle, we're going to once again do 180 minus 22.62 minus 134.41 and get another measurement of B, which is 22.97 degrees. And then find the second this is sort of like B sub 2, the angle. Now we're going to find little b sub 2. The other side, we're going to have this new b sub 2 over the sine of 22.97 degrees over, again, 7 over the sine of 22.62 degrees. B sub 2, 7 times the sine of 22.97 degrees over the sine of 22.62. Look how close these angles are. That's why you don't want to round off too much. And B sub 2 comes out to be 7.1 units. Now, to check to check whether or not these values are reasonable, we have our largest side opposite our largest angle, and our smallest side by just a tiny margin, 7, is opposite our smallest angle of 22.62. 22.97 is a little bit larger, and it's opposite, therefore, the slightly larger side. You have that same situation going over here. Basically, it's what your triangular inequality theorem. Your largest side is always opposite your largest angle. Your smallest side is opposite the smallest angle. Okay, our last example coming up where we only have another way of seeing that there's only one triangle when it's not necessarily a right triangle. So one more time visually. Angle of 22.62 degrees, adjacent side of 13. Little bit of sine of this angle equals h over 13, the height of that angle, if you will. And side combination is 5. Our first example, we had a length of 4, less than the height, didn't make a triangle. Actually, our first example had a height which was exactly 5. Set up the law of sine, you get, with the law of sine, that theta comes out to be, or side angle C in this case, came out to be 90 degrees. You open that, if you had that length of 7, we had a situation where we had two triangles because 7 was greater than the height of that ramp, if you will. This red triangle and now this green triangle. And now we have a length of 15. If you know that if the length opposite the given angle is simply longer than the side adjacent to the angle, you are only going to get one triangle, and you will get a triangle. What happens if you then try to open up a compass, rotate it around to see where the creation of that second triangle would occur? Well, are you ever going to intersect this line again? Nope. It's just going to swing all the way around, and the next time this side, which has a length of 15, hits the base of this triangle, if you will, if it's drawn in that orientation, is going to be right back over here. So when the side opposite a given angle is longer than the adjacent side, there is only one triangle. But if that little rule just slips your mind, no problem at all. take the information, draw a picture, side, side, angle, bad word, ambiguous case for dealing with the law of sine. You have that side, you have that angle, they're opposite each other, and we get the sine of 22.62 over 15 is equal to the sine of c over 13. Multiply both sides by 13. 13 times the sine of 22.62 divided by 15, do the inverse sine of both sides, or arc sine. We're going to call this C sub 1 because we recognize that it's an ambiguous case, meaning there's a possibility of two triangles, and that comes out to be 19.47 degrees. Now you've drawn the picture, you identified its side-side angle, that leaves the door for two possible triangles. You're going to find the first angle, you're going to immediately stop, you're going to take that, subtract it from 180, so C sub 2, the possible second measure of angle C, is equal to 180 minus 19.47 degrees. That comes out to be 160.53 degrees. Take that angle, add it with the original angle given to you in the problem. In this case, again, it was 22.62 degrees for angle A. And you're going to get a sum, which is, I'm not going to take the time to actually figure it out because 160 plus 22 is obviously greater than 180 degrees. So now this time, unlike the previous example, the first angle we found, taken away from 180 degrees, gives us a new possible second angle. Now the sum of that new possible second angle, whether it be A sub 2, B sub 2, C sub 2, plus the original angle given, this isn't a sum less than 180, opening the door for a second possible triangle. This sum is over 180 degrees. We cannot make a second triangle with this second possible measure for angle C, so this only has one solution. And now to finish this up, finding the third angle, of course, is not very complicated. 180 minus 22.62 minus 19.47 gives us an angle of 137.91 degrees. If you have seen the law of cosine, if not, it's going to be in the next lesson of your book, but we're going to go ahead and get ahead right now and look at it. When you have an angle included between two sides, then you can use law of cosine and say that b squared is equal to the other two sides squared and added together, minus 2 times those other two sides, times the cosine of that angle opposite the side you're trying to find. B is going to be the square root of all of that. And B is going to be approximately equal to 26.14 units. And I hope, and in summary, I almost forgot, if you don't find the height of that sort of ramp and recognize that when the opposite side to the given angle is less than the height, there's 0 triangles. If it's equal to the height or greater than the adjacent side, there's 1 triangle. And if the side opposite the given angle is longer than the height of that sort of ramp, but shorter than the adjacent side, there's 2 triangles. If you're not going to analyze these with geometry, then here's the steps. How do you set up any problem involving geometry? You draw a picture and label the diagram. If you recognize that your information is given to you in angle side angle or angle angle side, you're going to be doing law of sine. If it's side 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 or side angle side, you're going to be doing the law of cosine. If you have, though, side side angle, spell it backwards. Don't say it out loud. That's the ambiguous case for law of sine because it is, one more time, not a congruency theorem from geometry. So you're going to simply go ahead, set up your triangle, set up and solve for the first missing angle with the law of sine. You're going to get an acute measure because that's all inverse sine can give you. Find the second possible measure of that first angle you found in part B. If you found, B, then you're looking at B sub 1. Now you're going to do, not part B, but part 3. Then find B sub 2. We were finding sort of an angle C sub 1 in step 3. So C sub 2 in step 4. This will be an obtuse measurement. If the sum of the obtuse measure and the given angle, in our examples it was angle A, if that's less than 180 degrees, then set up a second triangle. Go ahead and give yourself a picture of both of them and solve for all the remaining missing parts of those two oblique triangles, non-right triangles. If the sum of the obtuse measure, again that A sub 2, B sub 2, C sub 2, like we were having with ours, if that sum comes out to be 180 degrees, then you've already taken up more than the number of degrees that you can make a triangle with, so therefore there is only one possible triangle. And I hope I didn't over-explain everything and kind of drag this on too long. I hope you have now a complete understanding of how to do law of sine, law of cosine, and more importantly, when given an information about a triangle in the format or the pattern of side-side angle, you will get those questions confidently and accurately every single time. I'm Mr. True. Bam! Go do your homework.